This is our first lesson in the inequalities part of our chapter, and it's going to feel a little bit like a review of what we did in 6th grade, but we want to touch on a couple of basics just to make sure you've got those down. In particular with inequalities, you have to be able to speak the language. You got to be able to know what words and phrases kind of are referencing each of the inequality symbols, so it's something that we need to review. So, writing and graphing inequalities. Like any good inequality lesson, the first thing we need to do is get down the inequality symbols themselves. So this first one we call less than, but you might also hear it referred to as fewer than. So you're going to want both of those in your notes. So you might make a little table of all of this information. Next one is greater than. That's its regular name, but sometimes the word or phrase more than is used to reference it. So to keep these two separate from each other, I always kind of think of it as the less than looks kind of like a capital L. It opens the same way that L does, so I know that that one is less than. This one is a less than, but it also has the bar underneath of it. Think of it as a combination of less than and an equals to sign. So we call this less than or equal to. So it could be less than our number or equal to our number, and we're okay with it. The two most common ways you're going to see it referenced in a problem is with the phrase at most or no more than. So something like you can invite no more than 5 people to your birthday party. That means you can invite 5 or less than that, but 5 is kind of the cap. It can't be any more than that number. And then our last one, our greater than symbol with the equals to sign underneath of it. That's our greater than or equal to. But again, some common phrases are at least or no less than. So if I said you need to get at least an 8 on your next quick check, that means you can get an 8 that's equal to or something greater than an 8 in order to get at least an 8 on your quick check. So let's jot these couple down and let's try to turn them into inequalities. So it says y is no more than 17. So we take our y, we take our 17, and we think about what does no more than mean? Well, if you look at your notes, no more than means less than or equal to. It can be equal to 17, but it can't be more than that. It has to be less than. So it's okay to be 17 or anything less than that. So y is less than or equal to 17. Here we have at most negative 8. So again, the most it can be is a negative 8, meaning it needs to be less than negative 8, but we're okay with being exactly negative 8. So we would say w is less than or equal to negative 8. Now we have some that are more of problems. We got to kind of decipher everything. This one says for more than a number. Well, more than means to add. And when we have a number, that's usually where we put in our favorite variable. So let's call it x is less than 13. Well, that means less than 13. And we do for more than a number. So for more than a number, 4 plus our number x. So this is combining a little bit of what we did in 6th grade and kind of putting it all together. Here it says the sum of a number, so let's call this one w. The sum means we're going to add it with negative 5. And then we have our word at least 10. That means it can be equal to 10 or greater than 10. We want it at least 10, so 10 or higher. So the sum of a number, w plus negative 5, is greater than or equal to 10. So it's just practicing kind of how to decipher these and kind of plugging them into an inequality form for us. Now for the part that you should have a pretty good recollection of from 6th grade, is graphing inequalities. This is where we take our inequality, we use an open or a closed circle. Open circle is when we don't want that actual number. So in this case, w is less than negative 6. So we don't actually want the number negative 6 because it's not equal to it. It has to be less than it. A closed circle is when we do want to include the number, when it can be equal to our number. So that's the less than or equal to or greater than or equal to. And then we shade in that side of the line that shows all the numbers that make your inequality true. So sample one is w is less than negative 6. So we put negative 6 in the middle. And my rule of thumb is I want at least 3 numbers on either side of my number in the middle. You can go farther if you want to, but I need at least 3. It needs to be a chunk of a number line. But I like to put my number right in the middle. I want less than, meaning I don't want to include the -6, so I'm going to use an open circle to say I'm going to start right here, but I don't actually want the number. And then I want numbers that are less than -6. So I think about what side of my number line are numbers that are less than -6. In this case, that's through my left-hand side. So I shade in the whole left-hand side, and I like to make a big arrowhead at the end, so it really stands out which side of the line I am plugging in. And then we always do a quick check, meaning taking any number over here that we tried, so say -9, and plugging it back in. So we put it in place of W. -9 is less than -6. Is it true that -9 is less than -6? In this case, that's true. So we know we shaded in the correct side. If you ever plug in a number and it doesn't make a true statement, that just means we shaded the wrong side and we need to go back and fix it. So let's do 3 of them together real quick. Again, you probably have a pretty good recollection of this, so feel free to work ahead if you think you're ready for it. But this one is 8 is greater than or equal to y. So be careful when your variable's over on the right-hand side. It's not quite as easy as you think it's going to be. But start with our number 8, that goes in the middle, and then we number going up and down. So we count up, 9, 10, 11. Then we count down, 7, 6, 5, 4. We want greater than or equal to. So anytime you see that or equal to, we're going to use a closed circle because we're okay with it being equal to 8. And then here's where you really have to be careful. 8 is greater than or equal to y. So if 8 is greater than y, that means y is less than 8 if we read it backwards. So I want numbers that are less than 8. So I'm going to shade in numbers that are to the left, that are smaller than 8. And then we check. So let's take 7. Is 8 greater than or equal to 7? Well, of course 8 is greater than 7, so we are good. But you're going to find that you're, as crazy as it is, as weird as it is, you're going to want to talk to yourself. You're going to want to say these in words instead of just looking at the symbol. Because if you actually say 8 is greater than or equal to 7, you can kind of realize what numbers work. If you just try to look at the symbol and think about it, it's often going to be something that you make a mistake with. Next one, G is greater than 2. So we put 2 in the middle, and we number going up, and we number, oh, you would think I would be able to count better than that. We count down. Remember, for your negatives, it counts down from 0, 1, 2, 3 as you go down. Here, G is greater than 2, so I don't actually want the number 2, so I'm going to use an open circle. And then I say it to myself, G is greater than 2, so I want numbers greater than 2. So I'm going to shade in all the numbers to the right, all the numbers that are larger, that are greater than 2. That's a really bad arrowhead, sorry about that. And then a quick check. So let's take 6. Is it true that 6 is greater than 2? It is, so we know we did it right. So let's try another one. -7 is less than or equal to m. So I'm going to start with my -7. Remember, in the negatives, it counts backwards in the opposite direction you normally would think of. And then it's less than or equal to, so I want a closed circle because I'm okay with it being equal to -7. And then here's the million-dollar question. Which side am I going to shade in? So this is where you say it to yourself, because when the variable's over on the right-hand side, it can often be tricky to do. But -7 is less than or equal to m. So if -7 is less than m, that means m is greater than -7. So I want numbers that are greater than -7. So I shade in nice and dark going to the right. Because all of these numbers, everything from -7 on up, all of those are solutions to my inequality. That's the whole point of shading it in, is because there's more than one number that will work. So let's try -3. Or if you wanted to, you could even go way out here and go to a 2, because you know that number line keeps going. Is it true that -7 is less than or equal to 2? Well, yeah, -7 is less than 2, so I know I'm good. So I can check any number on that right-hand side or on the side that I shaded in to check to see if my inequality works.